Welcome to part 2 of our COMP1511 extravaganza. We are continuing off with strings and file I/O. Oh, you can hear me now as well, that's fantastic.
It's good, isn't it? Isn't it good?
I may appear a bit less energetic than what I did earlier today. My apologies. So, we want to be able to interact with users, we want to be able to read stuff in, we want to be able to send stuff to the user. We've already seen this today with reading and writing to what we refer to as stood in, the standard input, and stood out, the standard output. Standard in is what printf, getchar, or printf and getchar use. When we write to stand out, that's using something like printf. We can use printf to display things like numbers using format string specifiers with %d for integers, %f for floating point numbers. We can display strings with %s in printf. Similarly, we can use scanf to read in numbers, like scanf %d to read in a value of an integer, or %lf to read in the value of a double long floating point number. Scanf will return the number of items it's managed to read. If we make scanf try and read in 5 numbers and read in 5 numbers, it will return the number 5 if it manages to successfully do so. If it doesn't manage to successfully read in all of the numbers, it will return a number less than 5. It will return the number of things it successfully read. If it expected to read a number, but it instead found something that it didn't like or didn't match what it was expecting beyond just getting to the end of a line, it will return end of file. So we can also use, and it will also return end of file when we've reached the end of input. So we can use this in a loop. Once again, I apparently need to add a heading to...
Capital.
What?
Capital.
What do you mean capital?
From the old Latin for head.
It doesn't help me at the moment.
Latin humour.
Latin humour. I needed a heading. So we can use this in a loop. So we can read in 5 numbers by scanning them in one at a time. And we say, whilst this is not the end of file and I haven't read in 5 numbers, keep reading in numbers. This means that if the user only put input 3 numbers and then Control-D or stopped reading from a file, this loop will stop and it will continue onwards. I will have the number of things we've managed to read in using this loop. We can read text using fgets if I wanted to read in, say, someone's name or a message that I wanted to send to someone, if I was implementing some sort of messaging service using the command line. Don't laugh, we used to do that. There was this thing called IRC. But if I wanted to read in, say, a message that I wanted to send someone, I could use fgets. We use fgets rather than gets. Gets does exist, it does read from standard in, but it has the shortcoming that it doesn't care how long your array is that you're reading text into. So if we're reading in text, it needs to be read into an array. That array can be on the stack or on the heap. In this case, you can see it's on the stack. It's in the same frame as the actual call. It's a buffer size, so we tell fgets this is how big the array is. It will make sure it puts it. It'll only read in a string that fits inside of that array, and it reads it into text. That is wrong. That slide has an error on it. Who can spot the error? Please tell me that's at the right end of that function.
Yep.
When in doubt, read the man page. So this will read from standard in, or stood in, and it will put it into that buffer. But that could be any other file style that we have. But yes, if I were to use just gets rather than fgets, it wouldn't know how long that array is, and it would just keep reading in until it gets to the end of a line. And if that end of a line happens to be something that lets the user write over a bit of a function and inject a calculator into your program, then so be it. Don't use gets. Use fgets. Fgets will return a pointer to the string that it managed to read in, which is useful, I guess. You already had a pointer to that. You gave it the pointer. But when it fails, it gives you null. So I guess that is useful. So if fgets returns null, it means you've reached the end of the file, or there was nothing more to read. So we can have a loop that goes through every line in a file using a loop like this. If the line of text doesn't fit inside of our text buffer here, it'll read the first part of the line as much as it can fit in the first round of the loop, and then when we go through the loop the next time, it'll put the rest of the line in, and it'll keep doing that until it gets to the end of the line. Yes?
Is there a typo for certain text that should be standard input?
Yes, there was 2 errors there that were the exact same error because I copied and pasted my code. Well spotted. Today's theme is professionalism and preparedness. Yes, correct. That should be stood in. Can be a bit confusing sometimes because sometimes you put the file at the end of the function and sometimes you put it at the start.
Or in the middle.
Or in the middle.
The C standard library is a great place to live.
Make sure you read the man pages because even those of us who have been programming in C for years and even decades still get it wrong. And then there's things like processing characters. If I wanted to go through a file one character at a time, I can use getchar. Or if I wanted to go through what was being typed in one character at a time, I can use getchar. That'll read a character and I'll hold on to one at any given point. That might not seem so useful, but sometimes you don't care about anything more than one character at a time because you're doing something like statistics on a file. There's this wonderful program which you can use called WC. And if I go to the thing where my code is, say ls, I say wc io.txt. It says 1886476 io.txt. Can anyone guess what those numbers might be referring to? That's what io.txt looks like. And then this gives me these 3 numbers. Yeah? Lines, words, and characters. So there are 18 lines, there are 86 words, there are 476 characters in this file. Sometimes useful to be able to do that. If you're writing WC, if you wanted to implement this program, would you use scanf? Would you use fgets? Or would you use getchar? Which of those do you think would be most useful to write this program? Who thinks scanf? Who thinks fgets? Who thinks getchar? How hard do you think how hard do you think it would be for me to find the source of WC of some variant? Let's see, BSD WC. Let's see what actually gets used. Let's search for the correct thing. See, there's all of these programs that live on your computer that hopefully at this point shouldn't seem so scary because you should be able to understand the code for them now and even write some of them now. It's just FreeBSD/WC.
Yep.
Oh no, it's.
Thank you, GitHub.
That's not GitHub. Useful.
Microsoft GitHub 365.
It's not what I wanted. Core utils, thank you. If I look at this code, what I'm going to see is I'm going to get down to WC. It's a bunch of extra weird syntax. They do weird things with braces. Bytes equals safe read, and does some extra weird stuff. Count complicated. Wow, they have really overcomplicated this program. I didn't realize they could make it this complex. This program you should probably be able to write in about a quarter of the number of lines that is actually used here. Over the folks over at GNU decided to use about 600 of them. But you could do this with getChar, is the point that I was trying to make. Apparently I didn't make that point well enough. But you could do something like this with getChar. You could do something like, if you had some weird encrypted file and you wanted to try and decrypt it, it might be useful to figure out what the most frequent characters are. It's an interesting form of cryptanalysis. Used to work back in World War II, World War I. You could do that with getChar. You can also redirect input and output when running the program. So if I wanted to give input to my program that was reading from stdin, but I didn't want to have to type it every time, and I knew I was going to be typing the same thing every time, I can store it in a file and I can send it into the input of that program. So instead of it waiting for me to type things in, it reads stuff out of this file. Likewise, if I want to store what my program shows on the screen into a file instead of showing me, I can redirect it out into a file using the greater than. I can even do these both at the same time. Doing something like that. But maybe it is useful for my program to be able to open files itself, read and write to files itself. So there are three modes. This is what happens when you rush to write slides. There are three modes in which we can open a file. We have R. So this R mode here says that we are going to be reading the file. And we will start reading the first character. We're going to call this file file. So if we had f gets some string, some array, some size, and then we said file, it would read from this file rather than reading from the standard in. We can write to files in two modes. The first is W, which says we're going to open this file and jump to the start of the file, delete everything that's already there, and then start putting stuff at the start of the file. And then finally we have append, which says we're going to open the file, go right to the end of the file after the last thing that was in there, and when we start printing, put things there. And then I have this table, which is not showing quite nicely, but use your imagination, maybe make it look prettier in your head. If I want to write onto the screen, I would use printf. But if I wanted to write into a file, I would use fprintf. The only difference between printf and fprintf is I give it the file star, the file pointer, as the first argument, and then the rest of it looks like the normal printf stuff. You give it the format string with your percents and your Ds and your %Ss and then all of the arguments afterwards. There's also a way to do this for strings. So I can say, here's an array of characters that I want you to fill in, and I want you to take this format string with these %Ds, these %Ss, this text, nicely formatted things, these variables, but instead of showing it on the screen, or instead of putting it in a file, I want you to put it inside this array, so I can use this array somewhere else. The function that does that is sprintf. Works just like printf and fprintf, except instead of to files, it goes to strings. When we want to do things like read numbers, integers, decimals, and whatnot, we would use scanf if we're just expecting things from users. Similarly, there is fscanf. The first argument of fscanf is the file that we want to read from. So this is something that's been opened in read mode. And it will do the exact same thing as it would for typing things in, but it expects to find the line that it's going to read in the file. The next line it would be up to reading. It will read that and try and interpret it and pick out the values. Like for writing, we also have scanf for strings. So if I have a string that's stored in an array, I can use scanf to read that string, pick out the values that are stored in it as text, and drop them into some variables. So instead of taking it out of a file or expecting someone to type it in, it looks for that text in an array as a string. If I want to read text that someone has typed in, someone's typing in their name, typing in a message, I would use fgets, but the first argument I would put, the last argument of fgets I would put would be standard in if I wanted to get it from the person typing in. If I wanted to read it out of a particular file, read the next line in a file, I would make that last argument the file star I am trying to read from, the file that I have opened. If I wanted to read a string from a string, it's a string. I don't have to do anything, it's already there. If I want to read characters from user typing it in, I use getChar. That gets me one character at a time. Each time I call it, gets the next thing the user typed in. fgetC is the equivalent for files. If I have a file open, I can pass it as the only argument to fgetC, and fgetC will give me the next character to be read out of that file. And if I wanted to get a character from a string, I just tell it which element in the string I want to read. Does that make sense for reading and writing values?
What does the getChar function return an integer instead of a character?
Why does getChar return an integer rather than a character? Is that your question? Yes. That is an interesting question. If I look at valid characters that getChar could return, it could return a 0 because all of these functions, when I'm talking about fgets and getChar, 0, what we usually call the null terminator of a string, is a valid character. It is something that these functions could read in. Fgets won't do it, getChar will. I think fgets will still read it in and it'll stop at the new line.
Fgets stops at new line.
So fgets will read in a 0 as well, so you might not get a full string in there. It's a bit weird, but 0 is a valid character. It's a valid thing to find in a file.
Yep.
Chars are 8-bit values. They store 256 different values from 0 to 255, or if we look at it as sign value, from -128 to 127. ASCII, which is the base standard we use for defining what numbers mean which letters and which symbols, covers the 0 to 127. That's what ASCII cares about. It doesn't care about the rest of the numbers. So most of your files will only contain character values from 0 to 127. It won't contain many of the low value ones from 0 to 31. It'll contain a few of them because that's where things like new line and tab live.
Why not 32, Curtis?
32 is space.
Do you ever have to know that?
No, you don't. Because remember, you don't need to remember which these numbers mean which characters. You just stick the character you want in a pair of single quotation marks, compiler figures out the rest. You should never need to look at an ASCII table in your life. And if you do, you should know how to make a program to show one to you for yourself. So those other things, those other 128 values could be used for something else. What they're used for kind of depends on the context. There's this cool thing called UTF-8, which you might have heard of, you might have seen referred to, which allows us to use those extra 128 values to signal to whatever is reading the file that what is about to come is a more complex number than just the value, just a number from 0 to 127. In fact, UTF-8 lets us say that this character that we're up to is made up of maybe this byte, this char, and the next char, or this char and the next 2 chars, or this char and the next 3 chars. So we can glue 4 of them together to have this character that has, some 17 billion? 2 or so million different values. That's enough values for, hopefully, every possible character in every single language you could think of.
And the poop emoji.
And the poop emoji. All of the emojis. That's how we represent those characters in files. The real point is, every value from 0 to 255 is a valid character. Where is EOF? getChar has to return EOF somewhere. It can't be one of these 256 values. So if I store the return of getChar in a char, it removes EOF. There is no way I can store EOF. EOF is -1. Valid characters are from 0 to 256. So we store the result of getchar in an integer so that we can distinguish between getting a character 255, which might be some part of more complex character, and finding the end of the file. So being able to distinguish those two cases. Char is not enough space to store that information. Does that answer your question?
So when you get an integer, then you convert it back to char if you want it.
Yes, you can. But you get the integer so you can check if you've reached the end of the file first. So it allows you to make that check properly. Any other questions about reading stuff in, showing things?
Oh, so you said UF is basically negative 1. So when I write the program, can I say while getChar is not equal to negative 1?
You could. That would look terrible and confusing to whoever was reading your code, but technically you could. EOF is a nice way of writing negative 1 in a way that says, I'm looking for the end of the file. If I wrote negative 1, it wouldn't be clear why I was doing that. Yes?
So it would still work if you had char, just if you encountered EOF.
It wouldn't break. What would break it is if somewhere in your text there is a byte that is that 255 value. You would see that byte in the file, which might only be halfway through. You might not get to the end of the file. But if you were storing it in a char, that would look like the end of file to you. You would not be able to tell the difference. Yes?
So, because you said that we don't need to memorize the ASCII table.
Yep.
All the substitution values.
Yes.
I needed the ASCII table to fit the same the lower and upper cases. Would that kind of question come up?
It could. You still wouldn't need the ASCII table for that. Because ASCII is structured that so that each letter in the alphabet comes one after the other. So B comes after A, C comes after B. This is the case for both lower and uppercase. So if I know the distance between uppercase A and lowercase a, then I also have the distance between uppercase B and lowercase b, and uppercase C and lowercase c. So if I can get the compiler to figure out what the values of those letters are, and I just find the difference between them using maths, I don't need to know the ASCII values, do I?
Better, there's even a function which will tell you if the letter's upper or lowercase.
Yes. So you've got is uppercase and is lowercase.
Is upper is lower.
Is upper is lower in the standard library.
So
yes.
If you get char, like a number, it'll come up with the ASCII value of that number, right?
Yes, it'll come up with the ASCII value of that digit.
What if you had, like, say, a number like 12, would it do 1 and then 2?
Correct. It's exactly what would happen.
And this is why we have things like scanf.
Scanf makes that easier. It's not really nice to go through and do that yourself. Yeah. Any other questions before I let Jashank talk about linked lists? I will let Jashank talk about linked lists.